You type riverbank and the AI predicts fish. Investment bank triggers stock. It knows instantly without understanding a single word. It's a trick of the light. The model sees the word bank and immediately branches into two distinct pathways. One leads to water and mud. The other leads to money and suits. It makes the right choice every time, yet it has never seen a river nor held a dollar. So, how does a system that only calculates word probabilities actually learn to write code, summarize essays, and mimic human conversation without ever truly understanding a thing? Treat them like magic oracles and you get burned by hallucinations. Treat them like calculators and you unlock a collaborator that actually works. You probably think these models are reading your prompts like a human would. But that intuition is exactly what leads to overtrusting them when they confidently generate plausible-sounding errors. You hand it a task, it gives you a smooth, authoritative answer, and you assume understanding. You don't. Think of a language model as a hyper-advanced autocomplete engine fed every book in a library. It does not learn meaning through experience. It learns the statistical probabilities of which words tend to follow others. The model predicts the next word. And since the GPT-3 breakthrough in 2020, scaling this task across billions of text snippets quietly absorbs grammar, facts, and style. It happens just by getting really good at the next word. But next word prediction sounds too simple to explain why modern models handle complex context. That is where the transformer architecture comes in. Introduced in 2017, it changed the game by using an attention mechanism to scan the whole context at once. Instead of processing words one by one, the model weighs relationships between distant parts of a sentence instantly. It can link a subject at the start of a paragraph to a verb at the end without losing the thread. And that attention mechanism is exactly why the model spots that bank means something completely different in riverbank versus investment bank. But that pattern matching ability makes the model sound incredibly fluent while occasionally drifting into factual inconsistencies. And in a second, I will show you the part nobody expects about why that happens. The part nobody expects is that the hallucination isn't a bug, it's the model succeeding at its actual job. It's not trying to tell the truth, it's just following the statistical path of least resistance, even when that path leads to a confident fiction. The model doesn't know it's lying, it only knows what is likely to come next. To make this work, developers train a neural network with hundreds of billions of parameters. These are just the adjustable settings the model tunes during training. Imagine a control panel with millions of tiny dials. Each dial controls a specific nuance of language. During training, the model tweaks these dials billions of times until the output matches human patterns. They act like millions of tiny dials, dialed to the precise combination that matches human language patterns. But tuning billions of dials is only half the story. Stick around because I am going to reveal the difference between a generalist model and a specialist, and why you might not need the massive model for your actual work. Pre-training gives the model broad language skills by predicting missing words across diverse text. It reads everything from Shakespeare to code repositories, building a massive general foundation. But fine-tuning narrows that focus by continuing training on a tighter, higher quality dataset. It turns a generalist into a specialist for jobs like legal contracts or medical journals. It takes that broad knowledge and sharpens it for a specific blade. This distinction matters because the landscape has shifted. We have moved past one-size-fits-all. The 2026 landscape favors choice. Smaller, mission-specific alternatives are running efficiently on everyday hardware. You no longer need a supercomputer to get the job done. That lets you deploy targeted AI without the jumbo jet compute tax of massive models. So the intelligence you see is actually a massive probability engine using attention to weigh context, tuned by billions of parameters and refined through fine-tuning. It is a pattern matcher, not a truth engine. That means you should use it as a collaborative drafting tool that excels at pattern matching and always verify outputs for bias or errors. Treat it as a partner in the process, not the final authority. If you want to see how this probability engine handles more than just text, watch our breakdown of vision and multimodal systems to learn how AI is starting to see and connect words to images. Subscribe for more no-nonsense breakdowns of the tech shaping your workflow. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day. And tap the video on screen to keep going. See you in the next one.